of intersection, those are the three things we're going to talk about. It's actually like P1 that we're going to look at. And so the very first thing we're going to talk about is how you sketch the graph. Now I understand you have a graphing calculator, but this I'm going to actually look for your work to see if you've done your work correctly. And so if you didn't have a graphing calculator, what could be a way that you could sketch the graph of y equals x squared minus 2?
Well, the thing is -2, so you already know.
Then you put the -2 at the y-intercept.
Oh, okay. Yeah, you could put the -2 as the y-intercept. Good call.
Oh, and x squared is not one of the things we last year.
Yep.
It's a parabola.
This is the stuff I didn't know.
It's a parabola, U shape.
Okay, it's a parabola. Good. So you guys remember them all. So you know that the y-intercept is -2, mainly because if you look at the equation, sub in 0 for x. That's what you get.
Yeah, that's right.
Now, how could you determine some other points? Because obviously we need more than one point on a graph. We know it's a parabola. We need to figure out, does it open up or down?
Up.
Why does it open up?
Because it's positive x.
You're right, positive x squared. So we know it opens up. We need to know if it opens skinny or wide. So how would I know what some other points would be?
Fill in random numbers.
Fill in random numbers. Basically, this is point plotting. So you have your x and you have your y. What could be an x value that you could plug in? 0. We already kind of did, because we've already got the 0 here. What would be another 1? So if I plug 1 in, what do I get? -1. So there you go. So now the nice thing about a parabola, you know that this -2 is the vertex, right? It's the lowest point. So where would be another point? -1, -1, because it's got to be the mirror image. Remember, it's on that one, and so there you go. Now, if you didn't know right away what the graph is going to look like, what I would suggest is starting with 0. So go ahead and start your table and go with 0, 1, and -1. Those are always three good points to start with. Okay? So 0, 1, and -1 if you have no idea what to do. So there you go. That's point plotting. Alrighty, now we're going to talk about x-axis, y-axis, and origin symmetry. Now basically you could probably not write maybe everything down, you could probably abbreviate a little bit. And what you could do is you could just do like symmetry at the top, and then you could start with x-axis. And you would go x-axis, and then you could put xy, arrow, x -y. So what I'm trying to do now is teach you a little bit of some note-taking techniques, especially when you get to college, because professors are going to breeze right through this. Okay? So at the top, I would probably put symmetry, x-axis, and I would write those three things. Okay? With that in mind, what would I do on the next one, do you think? Y-axis, xy, I would put an arrow, and then I would put this. Okay, so it's one of those things you kind of have to read and see. It says a graph is symmetric with respect to the y-axis if, whenever xy is on the graph, -xy is also a point on the graph. And then let's look at that last one. What's the last one going to be? What would be good, right? Origin, okay, x comma y, arrow, and then -x, -y. Now, once you get that down, we're going to go ahead and dissect exactly what that means. X-axis symmetry basically means that you've got a mirror on the x-axis and that the image is reflected. So what they're saying is that if xy is on the graph, then x -y is on the graph. And if you think about that, here's your graph, right? So if I had a graph that looked like this, if it has x-axis symmetry, that means that it's going to also look like this. And so when I think about that, here's my x coordinate, right? Here are 2 points. One is positive y, one is negative y. So basically, it's kind of the opposite.
So what would be an example if it's not? Like, what would be special?
Just anything that if you fold it over, it would not fold on itself. So if you had like a line, you know, if you had a line this way. Okay. And so y-axis is going to be the same way. Y-axis symmetry, except for with y-axis symmetry, you're going to have something that looks like, probably like this. Okay, and there it's going to be your x's that are going to be opposite. Now origin means it's flipped both ways. So that means it's flipped on the x and it's flipped on the y. So when I think of origin symmetry, I think of the odd duck. Origin symmetry means that if I start here and do this, to be origin symmetry, it's got to be reflected on the x and then reflected on the y. So reflected on the x means it would look like that. That would be x-axis symmetry, right? Now, remember, I've got to flip it and move it on the y now. So x-axis, or origin symmetry, would look like that. Okay? It's kind of one that looks like you folded it twice. All right, so now we're going to look at how you can test for symmetry without even graphing. So how do you algebraically test for symmetry? And we're going to look at two examples today. Okay, the first thing we're going to do is we're going to replace x with negative x. Now, this is testing for what symmetry? Y-axis. It's actually the opposite. Okay, so that's what we're testing for. When I replace x with negative x, that's testing for y-axis symmetry. So all I'm going to do is I get y equals 2 times negative x quantity cubed minus negative x. All right? So I want you to go and simplify that. See what you come up with. So you end up getting y equals negative 2 x cubed plus x, right? Okay. So I've already kind of simplified that. All right, now in order to determine if it has y-axis symmetry, these two need to match. Do they match? No, they're not the same. Why aren't they the same? Sine, sine. So as a result, this does not have y-axis symmetry. So, this is no y-axis. Nope. So then the next one, we're going to replace y with negative y. And what's this one going to test for? X-axis. Okay, so if I replace y with negative y, I get negative y equals 2x cubed minus x. Yep, and if you look, does it equal the same thing as the original equation? Nope, so that means there's no x-axis symmetry. So now we're going to do both. We're going to replace x with negative x. We're going to replace y with negative y, and this will test if it's got origin symmetry. So basically you're going to do both. So y becomes negative y, x becomes negative x. And so now I need to simplify. Now the nice thing is, if I were you, I would look back at some of the previous work you've done. You've already simplified the right side. The right side simplifies to this. Now if you look at it right now, it doesn't match, okay, per se, but what do you notice about all the signs? They're all opposite, right? So I can change each of those signs, boom, boom, by dividing everything by -1, and then now does it match? Yeah. And so actually this does have origin symmetry. Now this is a little test that you can do. If it has y-axis symmetry and it doesn't have x-axis symmetry, it is not going to have origin symmetry.
So there's one of the top two, you know,
All right, let's go ahead and look at the next one. You do this one for me. Test that for symmetry. And you're going to probably learn some tricks to do things in your head on this. Okay, does it have origin symmetry? Nope. Why does it have origin symmetry? It has y-axis symmetry. Okay. And these are some things that you're going to learn, some tricks of the trade. It's probably going to have like y-axis symmetry if you've got an x squared and a constant. Now, if you have an x squared and a variable, it's not going to have y-axis symmetry, but that's going to be, you're going to be looking for squares. But this one actually does have y-axis symmetry. Alrighty. So next one we're going to talk about is point of intersection of the graphs. This is very easy. Okay? And this is going to be the last part of your homework, the last few problems. And then that's good for today. Okay, now find the point of intersection means I want to see, do these graphs touch? And if so, where do they touch? And so there is a way to do this on the graphing calculator, but once again, we're going to look at this algebraically because we've got to go ahead and kind of review some of those techniques before we get going too much into calculus. So what would be a way I could find the point of intersection? What? Yeah, but I don't want you to do that. I don't want you to graph it. Okay? Reason being, I want you to do this algebraically. How could I find where those two intersect? Substitution or elimination, exactly right. Okay? So substitution or elimination, what do you want to do here? Do you want to do substitution or do you want to do elimination? What? Okay, you want to do substitution? Okay? Doesn't matter. If you want to do elimination, that's fine. You can go ahead and do that as well. Okay? Remember substitution, in this case, it'd be y equals 5 minus y. And then I'm going to plug that in here for x. So 3 times 5 minus y minus 4y equals 8. So you end up getting 15 minus 3y minus 4y equals 8. So, negative 7y equals what? Negative 7. So what do you get y to equal? 1. And so then now what you're going to do is you're going to plug that in right up here. So you really get x to equal 4. And your solution then is 4, 1. Now, you need to make sure you answer your solution as an ordered pair, not as x equals 4, y equals 1. Now, another way you could do that, Ross mentioned elimination. You could multiply this top equation by negative 3. You would get negative 3x, or you can multiply it by 4, plus negative 3y equals negative 15. And then you would go ahead and write your next one, which is 3x minus 4y equals 8. Then all you do is add those two together, and you get negative 7y equals negative 7, and you get your y equal 1 to start. So that's another way you can solve that. It doesn't just have to be substitution. So hopefully that kind of reviewed those two concepts. We're going to look at one more and then call it good for today. Okay, this one's a little different because if you notice, you've now got a power in there. So now anytime you have a power, you're not going to be able to use elimination. Okay, you're going to have to use substitution. So what you're going to do is you're going to look at that top, sugar sink. You're going to look at that top equation.
Sugar sink.
It is sugar sink. It's a kind of way like Dropbox that'll actually
No, I
sink.
know. I thought you were like saying sugar sink is like a line.
Oh.
That's what I thought she was
Oh,
saying.
sugar sink.
Okay, so I'm going to go ahead and solve that top equation for x. So top equation for x, I'm going to get 1 plus y. So then down here, I'm going to get 1 plus y minus y equals 3. And that's quantity squared, by the way. So now I need to go ahead and FOIL that out. So if I FOIL that out, what do you get? 1. 1 plus 2y plus y squared minus y equals 3. Remember when you FOIL those out, you're going to have 1 plus y times 1 plus y. You have to do first outer inner last. Okay. Now that's one of those things that if you can remember the shortcut, it's first term squared, twice the 2, last term squared. Okay? First term squared, twice the 2, last term squared. All right, so now let's go ahead and get everything over to one side of the equation. So I end up getting y squared plus y minus 2. Now, why did I want to move everything to the left side? Because this is a quadratic, okay? In order to solve a quadratic algebraically, you need to have it equal 0. Because now you can factor. 2 factors of 2 that do what? 2 factors of 2 that differ by 1. What are those 2 factors of 2 that differ by 1? 1 and 2. How do you get a positive 1 from those? Negative 1, positive 2. What goes first in the parentheses? Y. So in this case, if you notice, you have 2 values of y, 2 possibilities. What are those 2 values going to be? Y equals 1, y equals negative 2. So now what you need to do is sub each of those in there. And so if I sub in 1, I get x to equal what? 2. So my first solution is 2, 1. If I sub in negative 2, I get negative 1. So my next solution is negative 1, negative 2. So anytime you have something with a square, you're probably going to have 2 solutions. And in fact, if you have 2 squares, in each equation, you're probably going to have 4. Alrighty, so this is what I need you to do. Page 8, 1 through 4, 5 through 13, the odds. 27 through 31 all, and 61 through 68. Now, a little bit about this. Remember, this isn't due tomorrow. This is actually due when we take the Chapter P quiz, which I would shoot for maybe Tuesday, Wednesday. So.
Where's my first one?